Hello, my name is Steve Bowler, and in this lab we're going to be taking a look at Open Shortest Path First, otherwise known as OSPF. Specifically within OSPF, I'm going to show you how to configure single area OSPF on a Juniper router. And in this example, we're going to also explain to you some of the basics of OSPF and how OSPF works on a broadcast multi-access network type such as Ethernet. So in this lab, in the diagram, we have two routers, router 1 and router 3. Router 1 and 3 are connected to each other via their gig E001.0 interface. And these two routers are on the 13.13.13.0/24 subnet. Router 1 has the .1 IP and router 3 has the .3 IP. Router 3 also has a loopback 0.0 interface with the 3.3.3.0/24 network and also the 33.33.33.0/24 network. Router 1 also has a loopback 0.0 interface as well with the 1.1.1.0/24 network and the 11.11.11.0/24 network. And it should be known that all the interfaces in this lab that we are going to be configuring are part of OSPF Area 0. So real quickly, what I'm going to do is just sum up some of the basics of OSPF running on a broadcast multi-access network. Within the broadcast multi-access network type, we're going to see that there is an election that takes place so that all of the routers know which router is going to be designated as the designated router, and also we're going to have the backup designated router. And the point of these two routers within the broadcast multi-access network type is so that, say we had 10 routers on a local network and they were all broadcasting their LSAs for OSPF and LSUs. Well, that would take up a lot of bandwidth, and what we're going to see with OSPF is that it is a very chatty protocol. There's a lot of LSAs and a lot of events happening between our OSPF neighbor adjacencies. So the whole concept of having a DR and BDR is that those 10 routers will synchronize their information with the DR and send updates to the DR, and likewise the DR will send information to all the other routers that are not the DR. So in this case, the backup designated router is also used along with the designated router, so that if the designated router is offline or goes down, the backup designated router will be able to come up and act as the designated router within a moment's notice. And all the routers in each area run what is called the SPF algorithm, or the shortest path first algorithm, and store a map of the network in what is called their link state database. And these link state databases are identical within each area. What we're also going to see is with OSPF, Area 0 is known as the backbone area, and all other areas must connect directly to Area 0. Unless, of course, you are using tunneling or creating what's called a virtual link. But in this lab, we're not going to look at connecting multiple areas to OSPF. We're going to just take a look at single area OSPF. I'm going to show you how to set up OSPF on Juniper routers. And we're going to take a look at setting up some trace options. If you're not familiar with trace options, you can watch my trace options lab where I show you how to set those up and how to look at the trace options. So we're going to do that. And within the trace options, I'm going to show you some key events that are going to happen. I'm going to show you how the OSPF neighbor relationship forms and how the designated router and backup designated router get elected, and what key features the designated router has in order to get elected. So let's go ahead and get started. Let's start by configuring let's go ahead and start by configuring R1. And let's go ahead and we'll just configure our interfaces first. So set interfaces gigi 001.0, family inet. The address we're going to put in is 13.13.13.1/24. And also we're going to create our loopback 0.0, family inet with the address of 1.1.1.1/24. We're also going to put in the 11 network, so let's go ahead and do that while we're at it. So now that router 1 is configured, let's go to router 3 and get it configured as well with the basics. So we'll do the command set interfaces gigi 001.0. Again, this is the logical interface on the physical that's connected to gigi 001. We're creating logical interface 0. We're going to put on it the IPv4 address of 13.13.13.3. Again, that's a /24 subnet mask, and we're also going to go ahead and create our loopback 0.0. We'll give it the IPv4 address of 3.3.3.3/24, and also we're going to put in 33.33.33.33/24. Let's go ahead and commit these changes and we'll quit. And we should have basic reachability between the routers, so I'm just going to do a quick ping to router 1. So we're going to ping 13.13.13.1, rapid count of 100, and we can see that we have reachability. So what we're going to find out is on Juniper routers, it's pretty simple how to set up the basics of OSPF. We're just going to set up area 0 on all the interfaces that are in this diagram. We're also going to run some show commands for verification of our OSPF neighbor relationships and show you some of the other cool commands within OSPF. So the first thing we're going to do is on R1, let's go ahead, and the way we're going to configure OSPF is we're going to go under Edit Protocols OSPF and hit Enter, and that's going to take us to the Edit Protocols OSPF hierarchy within configuration mode. What we're going to see with OSPF is that we are going to use the set statement, and we're going to use the option of the area option next. So this is going to be used to configure an OSPF area. So we're going to do set area, and we're going to see if we do a space question mark, you see that we have an area ID. And this area ID can be written out in dotted decimal format. So set area 0.0.0.0, or you can also just do a set area 0. So on router 1, I'm just going to do a set area 0.0.0.0 to show you how that's done. And then on R3, I'll just do a set area 0 to show you that it doesn't matter which one you put in, that it's going to perform the same operation and create that interface into area 0. So we'll do the command set area 0.0.0.0. We'll do a space question mark. You can see that we have the option for interface, and this is to include the interface into the area. So we'll do set area 0.0.0.0 interface, and then put in our interface, which is gigi 0.0.0.1.0. I'm sorry, 0/0/1.0. We're also going to put in our loopback. So we'll do loopback 0.1. And now on R1 we'll do a commit and quit. With that being said, let's go under R1 again, and we'll set up our trace options on R1. So we'll do Edit Protocols OSPF, and then under the OSPF configuration, we're going to do the command set trace options, and then we'll create our file name for our trace option, which is going to be called OSPF Lab 1, and we'll create a bigger size than default trace option file size, because we're going to see again that OSPF by default is going to be there's going to be a lot of LSAs, which is link state advertisements, going across from the routers, a lot of updates, a lot of events happening with OSPF. It's a very fast protocol, but that comes with the cost of bandwidth and the amount of information exchanged between all of your routers. We're going to do set trace options file OSPF Lab 1, size 1, I believe that's 1 million. Then we're also going to do the command set trace options flag all. So we're going to create a file called OSPF Lab 1, and we're going to dump all of the trace options into this file. So if we do a show log OSPF Lab 1, you can see already, even though I just turned it on, the trace option, you can see we're getting a lot of information. Also, one of the first commands you can see that I'm going to do and show you is the command show OSPF neighbor, and you can see by doing this we have nothing right now. We have no neighbor relationships, and that is because we still have to go under router 3 and set up OSPF on it. So we can see right now that on R1, let's do this. So you can see right now that on R1 that we're sending hellos out of our gig E001 interface. With that, we're given the multicast address of 224.0.0.5, which in OSPF is the all SPF routers. So this is the update information, our hello traffic going out to try to find neighbor relationships on the link. And in this case, we're going to see that we will be successful in doing so once we configure OSPF on R3. So on R3, let's go ahead and get OSPF set up. We'll go under configuration mode, and we'll do the command edit protocols OSPF. From here, this is again very simple to configure neighbor relationships between, very simple to advertise interfaces into OSPF. The way we're going to do this on router 3, we're just going to go under router 3, and we'll do the command under edit protocols OSPF. We're going to do the command set area, and then I told you on router 3 we're going to set the area as 0 instead of dotted decimal format of 0.0.0.0. If we go back to router 1 and we do a show configuration protocols OSPF to look at the OSPF configuration, you can see that the area type shows up as 0.0.0.0 in the configuration. So let's go back to router 3. We'll set the area of 0, and we're going to put in our gig E interface, which is 0.0.1.0. Then we're also going to put in the loopback 0.0 interface. Go ahead and commit and quit. And now, if I do a show OSPF neighbor, you can see that we don't have a neighbor relationship yet on from router 3's viewpoint. On router 1, if I do a show OSPF neighbor, you can see that just that fast we're seeing now that we're getting a neighbor relationship with router 3. We see the address of the distant end. In this case, router 3 is the .3. The interface in which the neighbor relationship is formed. We see the state, the OSPF state is full, which we all know that is exactly what we want to see with OSPF. If we see anything else, then we know that we're having issues with the neighbor. We see the router ID of the far end, in this case is 3.3.3.3. And we see the OSPF priority, which is 128 by default. We see our dead timer. So a couple of things right off the bat. We can see that OSPF convergence time is very fast. On router 3, if I do show OSPF neighbor, now we can see that I have my neighbor adjacency with router 1, which is reachable over my gig E001 interface. The state is full. My router ID on the far end, which is 1.1.1.1, We have the priority of 128, which is the default OSPF priority on Juniper routers, and we see our dead timer. Let's go to router 1, and now let's do a show log OSPF. In this case, what I'm going to do is I'm going to show you some of the OSPF neighbor events. If I do a show log OSPF Lab 1 pipe to match, and then what I'm going to match is OSPF, then I'm also going to match neighbor. So what this is going to do is this is going to show us the OSPF process, some of the good information that we're getting with our OSPF trace option. We have the state change from down to init, and then this is because we received a hello back from router 3. Then we see the state change again from init to exchange start. Then we see another change from exchange start to exchange, and then exchange to loading, and then finally we see loading to full. So we can see the whole OSPF neighbor process by doing this command, the trace options. It's very cool stuff that we can see. So it's very important also if you're having problems with an OSPF neighbor relationship forming, your trace options are going to be a very valuable help to you for trying to find out and troubleshoot issues when trying to form your OSPF neighbor relationships. Also, I want to show you within the log file, if we match on the DR keyword, we can see that we can see the process of electing the designated router on the link. So we see the process from the beginning, when the designated router from router 1's viewpoint is itself, which is 13.1, there's no backup designated router. Then we can see by the end of the process, the designated router shows up as R1, and the backup designated router shows up as R3. If I go to router 1 and do a show OSPF neighbor detail, we can see that on the link we have the designated router is us, which is router 1, because we have the 13.13.13.1 IP address. The backup designated router is router 3. If we go to router 3 and do a show OSPF neighbor detail, we can see the designated router as router 1, and we are the backup designated router. So the way we can change this behavior is pretty simple. So we see that the designated router was elected on this link, and that router 1 has become the designated router. The default priority, remember, within the OSPF link is 128, so 128 we have on both sides, and we can influence the election process of the designated router by setting the router ID on one of the routers. So in this case, R1 is the designated router. If we wanted router 3 to become the designated router, what we're going to do is we're going to set the router ID to be the highest IP address. And then we're going to see what happens. So on R3, we're going to do this it's very simple to do this, and the command to do this is actually, we're going to go under Edit Routing Options, I believe, and under Routing Options I'm going to do the command set, and then we can see the option for the router ID. So this is the router identifier. And we can set the router ID. In this case, we'll just set it to the highest IP address. And the router ID, again, if we're looking at the network diagram, the priority is the same. And if that's the case, the next highest thing that wins the election of the DR, or the designated router, is the router ID. Let's go ahead on router 3 and we'll set the router ID to make it the highest. We'll just create it as 200, 200, 200, 200. We'll commit and quit. And then what we should see is now from router 1's point of view, remember router 1 was seeing router 3 with the router ID of the 3.3.3.3. Now if I go onto router 1 and do a show OSPF neighbor detail, you can see that we have the router ID has changed to all 200. But as we can see, OSPF still sees the designated router on the link as router 1. And this is because by default, just because we changed the router ID on router 3, router 1 is still going to become and be the designated router until an event happens into which the election process is restarted. And one of the ways we can influence the election process is if we just go ahead under the interface, we'll just do a set interfaces gigi 001 disable. So we're going to just bump the interface. So now that the interface is down, we'll go ahead and admin it back up. And what we should see now on R1, if I do a show OSPF neighbor detail, we see that the election has not yet occurred. We see the designated router of all zeros, the backup designated router of all zeros. We see the state again is in two-way. So this, once the state is full, then we should see the designated router and backup designated router election. So we're going to let this happen, and this should form in a minute. And now we see that the designated router is 13.13.13.3, and the backup designated router is the local router from router 1's point of view, which is the .1. From router 3's point of view, if I do a show OSPF neighbor detail, we can see that the designated router is locally, which is router 3. And we see the backup designated router is router 1. In this case, the router ID we manually set on R3 to be 200, 200, 200, 200, and that is what won us the election process as the designated router on router 3. Once again, I want to show you, if I do a show configuration protocols OSPF, like I was showing you earlier on router 3, when I put in just area 0, we can see that in the configuration it actually put that out in a dotted decimal format. So that's how it looks like in a Juniper router. So area 1, going by this logic, would be showing up as 0.0.0.1. Now let's go ahead and take a look at some of the other show commands. To look at the routes in OSPF, we haven't even looked at the routing table yet. On router 3, if I do a show, if we want to take a look at the routing table, we'll do the command show OSPF or show route protocol OSPF. And in this case, this is going to show us all of the routes in the routing table that have been learned via OSPF. We can see that the default the default route preference within OSPF is 10. And we can see the next hops for the 1 network and the 11 network, which is the loopback 0.0 subnets on router 1. We can see the next hop is 13.13.13.1, which is router 1. Let's go ahead and try to ping these. We'll do a ping 1.1.1.1 from the source. We'll source this from our loopback, and we can see that we have reachability. Again, if you're not familiar with that, we'll do a rapid count 1000, and we have reachability. So from router 1's point of view, we'll do the same thing. If I do a show route protocol OSPF, we can see the OSPF learned routes that are in the routing table. We have the 3 network and the 33 network. Again, these are OSPF with a route preference of 10. Another really good command is show OSPF overview. And from router 1's point of view, we can see that the router ID is 1.1.1.1. We can see the different areas. In this case, we only have single area OSPF running, so we see area 0.0.0.0. It's going to show us if we have our stub types, our authentication, if we have any running, our neighbors. We have up in the full state, we have 1, and a lot of other good information. So what we have seen in this lab is we explained to you the basics of setting up single area OSPF on 2 Juniper routers. We showed you how the designated router and the backup designated router get elected. The 2 important features there are the OSPF priority on the link, and if that is a tie, then the second thing it goes to is the router ID. We went ahead and we set the router ID on router 3 to be the highest. We set it to 200, 200, 200, 200 because we saw that router 1 was the designated router by default. So we influenced the designated router, the DR-BDR election, by having router 3 have the highest router ID. Then we bounced the connection between R1 and R3, and we saw that router 3 was then the designated router on the link. We also showed you the trace options within OSPF. We showed you the neighbor relationship process and how that can be very useful when troubleshooting OSPF issues. We explained how to set up OSPF on the 2 routers and how simple it is. On router 1, if I do a show configuration protocols OSPF, we can see that we have area 0, and we just added the interfaces into the area. And that is all we had to do. If you were with me and you saw my RIP version 2 lab 1, my Juniper RIP version 2 lab 1 video, you saw how hard it was to set up RIP version 2 just to advertise its local interfaces. We see that OSPF is a completely different is completely different in the means that it is a lot simpler to get up and running. So all we had to do was advertise the interfaces into OSPF, and the neighbors found those. We got a neighbor relationship between R1 and R3, and the last thing we did is we looked at the routing table and verified that we could ping between our OSPF learned routes. So thanks for watching, and I hope to see you in the next video.